Okay, so if you're going to be watching this video later on, you should pause this, read through everything, and do parts A, B, and C on your own, and then hit play and grade or check your work as we go. So here's what we got to start. The figure below, or on the side here, gives us the graph of f prime. So this is the graph of the derivative of a twice differentiable function, which means the derivative exists twice. If you see twice differentiable, we also know that it's continuous for all of f. So this is a nice continuous graph for f on the interval from -3 to 4. And the graph of f prime has horizontal tangents at x equals -1, 1, and 3. Now, that last statement is actually one of the answers to these A, B, or C, which is kind of nice. They give you the answer if you notice what they're telling you about horizontal tangents. So we'll make reference to that. But let's do part A. Find all of the x coordinates at which f has a relative maximum. Give a reason for your answer. So that's really important. You do have to provide a reason, and that reason has to be calculus related. So what I would recommend doing is, and by the way, you technically do not have to show any work for this problem. If you know exactly what part A is asking, looking from this graph, you can write your statement and provide your reason without any of this work. And that's kind of the goal, is your goal is to get through this or get this problem done as fast as possible. So what I'm going to do though is say, okay, wait a minute. If f has a relative maximum, what do I need to know about the derivative if f has a maximum? Well, there has to be a derivative of 0, which, by the way, the horizontal tangents, or I'm sorry, nope, that's not for this one. So f prime of x has to be 0, and if we have a maximum, f prime of x has to change signs from positive to negative. All right, now this is what my brain is thinking. I'm not writing this down right now, but I'm looking at this graph and I'm gonna, if it really helps, I'm gonna make a sign chart. And I want to focus on the spots where the derivative is equal to 0. So here's the graph of f prime, and I know at -2 I've got a 0 derivative. I know at 1 a 0 derivative, and I know at 4 there's a 0 derivative. And then I'm testing the sign chart to the left and right of those points. Well, notice this is the graph of f prime, and I'm above the x-axis, so the slopes would be positive here. And then everything else is below, so those are all going to be negative. And we're looking for when is f prime equal to 0, and there's a sign change from positive to negative. So you can see the derivative goes from positive to 0 to negative, which means my first answer is -2. And here's my justification. So technically, this is all I need to write for part A. I don't need to show anything else. F has a, and notice I'm relating back to the original function. F has a relative maximum at x equals -2 because f prime changes sign from positive to negative. That's all you need to write, and you're done. Okay? Now, part B is a little bit harder. Part B says on what open interval from -3 to 4, so that we're basically saying we're not counting these endpoints. So this little value 4 isn't part of our interval here. But we're looking for when is the graph concave down and decreasing? Well, decreasing is when the derivative is less than 0. And we know it's decreasing for this entire value, right? But concave down is when the second derivative is negative. So I need to make a sign chart for the second derivative here. And I don't have a lot of space, so I'm going to do that right above here quick. And I'll go, unfortunately, I'm going to go into this slide here. So I need to look for where do I have slopes for the f prime that are 0. Well, that's what they gave me, horizontal tangents. Right here at -1, this is in a different color. Right here at -1, I've got a 0 degree or a 0 slope. So that means the derivative of the derivative of f double prime is 0. At 1, I've got a 0 slope. And at 3, I've got a 0 slope. So those are where my second derivative is equal to 0. Now I'm going to check the sign value of the points to the left and right of these. Well, notice, now we're checking the slopes of this line. So the slopes of this part, or notice f prime is decreasing, so that automatically means we're concave down, so it's negative. And then we're increasing slopes from -1 to 1, so the values are positive here. And then we're decreasing from 1 to 3, and then we're increasing again. So notice I have the intervals now where I'm concave down and concave up, but I want to know the intervals where I'm both concave down and decreasing. So I'm not sure if this is going to work the way I want it to, but here are the values where I'm concave down, and then here's the values where I'm decreasing. Well, what's the overlap? I need to get exactly both of those values. So notice, at -2, I would be right here, and then I'm negative and decreasing until 1. So I'm going to go from -2 to -1. Maybe I'll put a little interval there. That's where I'm both decreasing and concave down. And then also, since the rest of this is decreasing, it's also going to include the interval from 1 to 3. So here's the answer for part B. F is both concave down and decreasing on -2 to 1 and 1 to 3. And again, you could do all this work without any sign chart or anything. All right? And then what's our justification? You have to provide a reason. Well, why did we know that? Because we know that f prime is negative, that means it's decreasing, and f double prime is negative, that means it's concave down. All right? And then part C is find the coordinates of all the points of inflection for the graph of f, give a reason. Well, the points of inflection occur where the second derivative is equal to 0 or does not exist, and there has to be a sign change. So here's the benefit to doing the work that we just did. Get rid of these pieces. I need to find the spot where the points of inflection occur. That's where the second derivative, which is right here, is equal to 0. And that's those horizontal tangents. Notice they gave us that answer right here. So part C, they gave us the answer, but we have to be able to justify why are those the points of inflection. Well, notice I go from concave down to concave up to concave down, and concave down to concave up again. So there's a sign change in the second derivative at those points. And here's my answer for part C. F has points of inflection at x equals -1, 1, and 3, and then y. F double prime is equal to 0, and F double prime changes signs. All right, so let me show you one next slide on how would they grade this, because that's the other thing we're going to kind of talk to you about. I did cover up part D because we don't know how to solve that yet. But when they give you a free response question, every free response question you're going to get on the AP test is worth 9 points. And you have 6 of them total. So that's a total of 54 points, which is usually exactly half of the AP test value. Now I'll give you a little hint, and we're going to talk more about the scoring guide. But if you can score anywhere from 4 to 5 points on every free response question, that alone will get you a 3 on the AP test. And that's not even counting the multiple choice questions. So that's a little bit motivating. You don't have to get 100%. In fact, it's actually really difficult to get 100% on every question. So let's just quick look at this. How would they grade parts A, B, and C? And again, this isn't out of 9 points because I eliminated part D, but each one of those was worth 2 points. So what did they do for part A? If you identified your answer as x equals -2. Okay, if you identified that answer, that was 1 point. But then you had to provide the reason, and if you don't correctly provide the reason, then you don't get that extra point. All right, so their justification, they actually provided the reason first, is f prime changes from positive to negative at -2. So that's maybe I'll do this. That's the reason part. That was worth 1 point. And then their justification was, notice what they do. They don't say it has a relative maximum. They say f. You always want to refer to the function by name, so you're being very specific in your answer. F has a relative maximum at -2. Okay, so that's how you would earn the 2 points for part A. Part B is basically the same thing. You got 1 point for the correct intervals. Now you could use this notation. Okay, and I think they would give it to you if you put -2 to -1 and 1 to 3, but you should say what you're answering. You know, what is the problem? What are those intervals? It's f is concave down and decreasing. So the perfect answer would be everything in yellow is equal to 1. All right, and then your reason. Now, this reason is a little bit different than mine, and that is one thing. They do accept all possible answers as long as it relates to calculus. We said because f prime is less than 0, which is the negative part, so that's part we said. But then they said f prime is decreasing. We said f double prime is less than 0, which is the same thing. So that's how you would get that second point. Okay, and then part C, you have to say what has the points of inflection. So we're talking about the original graph f. F has a point of inflection at -1, 3, and then they split it up. So to my knowledge, we would get the credit that we answered the question, but they said, well, here are your answers, -1, 3, and 1. And then they split up the justification a little differently. We said because the second derivative changes signs. They said because f prime goes from decreasing to increasing for these points, and then they said f prime changes from increasing to decreasing for these points. So they were more specific, which is always better. But that's how you would earn those 6 points for this part. So I hope you can look at this and say, you know what? I might be a 5 out of 6 right now, or I might be a 1 out of 6. Regardless of where you're at, can you always do a little better? And that's what we're going to get to with practice, is once we get to the actual AP test, we'll have done so many AP questions that you're going to be really comfortable and ready for it. Okay? All right. What we're going to do. Okay, so we're going to go through this quick and give you guys some feedback. It's been a while since we've done anything with the implicit differentiation. And I can say with some confidence that I feel like this is going to be an AP question on the test, is this concept where you have to understand what they're doing. Now notice what they gave us the derivative already, so we actually don't have to do that work. We know this is the derivative. Well, what's another word for derivative? Slope. And what they're asking us for is write the equation of the tangent line. So right away, I'm thinking I need a slope and I need a point. Well, they gave me the point x1, y1, that's these two spots, but that same x1, y1 can be plugged in here to find the slope at the point -1, 1. So I'm going to do that first, and actually let's do it down here. And your notation doesn't have to match mine perfectly, but this is the notation they use for the slope at this point. And then all we're going to do is wherever I see a y, we're going to put in 1. Wherever there's an x, we're going to put in -1. And then simplify. And when you simplify, you end up with 3 plus 1, or 1/4. So there's my slope. And my answer is plug the slope in for the m, and then the x1, y1 go in here. And my advice, stop right here. There's nothing wrong with that algebraically. You're done. But they would accept any algebraic form. So if you wrote it like that, it would be acceptable. If you wrote it where you distribute the 1/4 and then add 1, but notice this 1 is going to have to add with the 1/4. So instead of calling it 1, I'm going to call it 4/4. So any form that I have here, or even if you just put the +1 on this side, so if you brought this -1 over here and put a +1, that would be acceptable as well. So any correct algebraic form of this is acceptable. And I believe that's probably worth 1 point, maybe 2. Actually, I think I have the answer right here. That's worth 2 points. You got a point for the slope, and you got a point for writing the equation of the tangent line. And notice that's how they wrote their answer with the +1 over. So that's how you get the 2 points there. All right, let's go back to part B. Part B says find the coordinates. Now notice that's plural of all points. So we got to find both x and y of all points, which makes this tangent line vertical. Well, when I think of that, I'm thinking my slope. All right, I'm thinking my slope is vertical. Well, wait a minute. If the slope is vertical, straight up and down, that means the derivative or the slope has to be undefined. So I'm going up here and I'm saying, when is this function undefined? It's undefined when the derivative, when its denominator is equal to 0. All right. Now, notice we're not using the xy, x1, y1 point that was given. We're looking for the point that makes this relationship true. So what I'm going to do then is I'm going to bring the x over here, and I know how x and y are related. Okay, so I now want to find x or y. Well, if I go back to the original problem, and I know what x is equal to, I'm going to plug in 3y where there's an x. So we're going to find y using this relationship. Right? So we're given in the original problem, I've got 3 or y to the third minus x times y, but instead of putting x, we're going to put 3y squared here. And then it's just algebra. Now we have one variable. So y squared times y is y to the third. And technically we could put a 1 in front here, and that gives me like terms. And then I'm going to divide by -2. And then I'll take the cube root, and the cube root of -1 is equal to -1. So notice there's only one y value, and I want to find the coordinates. I want to find all points, which my answer needs to be in xy. So that just means once I find y, now I got to figure out what x is. But I'm going to use this relationship that I just had. We know how x and y are related, so I'm going to plug y back in. -1 squared is 1 times 3 gives me 3 comma -1. And there is the point at which the derivative or the curve of the tangent line is vertical. That's where the derivative would be undefined. Okay. Now, those two, that was worth probably 2 points as well. We can do a quick check here. Actually, as I worked, that one was worth 3 points. If you were to just set the denominator equal to 0, even if you solved it wrong, you got 1 point for setting the denominator of dy dx equal to 0. And if you got the relationship, it says the equation in one variable. So if you had a spot where, I'll show you that right here. This spot right here where you used this answer and plugged it back in. So if you got this, you got 1 point for just using the y back in the original problem. And then your final answer was just solving for y, solving for x. So that's how you got the 3 points. Okay, to save time, I'm going to take and show you part C on the next slide. I had this already worked out from my work. So part C is a little bit tricky. And I'll try to just highlight the part C part here. So what do we need to do here? Okay, they're saying find the second derivative. So I have to take the derivative of what was already given, which is the quotient rule. So I'm going to take the derivative of the top. And let's look at that. The derivative of y is dy dx. So it's the derivative of the top times the original bottom minus the original top times the derivative of the bottom. Now notice, if I take the derivative of the bottom, the 2 comes down. 2 times 3 is 6. That's where that 6 comes from. And it's 6y. But then I took the derivative of y, which is dy dx. And that's important right here. You need a dy dx here and right here. Because anytime you take the derivative of y, dy dx comes into play. And then I've got the derivative of x, which is just 1. So that's the top part of the quotient rule. The bottom is all over the denominator squared. So I'm just going to leave that as is. But now notice, they want me to find the derivative at the point -1, 1. And this is the part that I think it's important for us to understand, and it can really save us some time. Right here is dy dx, and right here is dy dx. Well, I need to evaluate dy dx at the point -1, 1. Didn't I already do that? I did that in part A. That was my slope, which was 1/4. So you don't need to show the work for that. All you need to do is say, when you see dy dx, plug it in as 1/4. And that's where this 1/4 came from, right here, and this 1/4. Everything else, I'm plugging in x and y. So I'm going to plug in -1 for x and y for 1 in all these spots here. And then it's just kind of an organized mess. We're simplifying, and they would accept any algebraic form of this. So technically, they would accept this. If you stopped right here and didn't do any simplifying, but it was all numbers, assuming every single number was accurate, that's good. You don't get any extra points for simplifying. But since this is a practice round, we do want you to go ahead and simplify, and at the very end, you should have got 1/32. Okay. And by the way, I will post this on Notes, so you can always go back and check. I do want to show you how would they grade this problem, right? So it's a 4-point problem. You got 2 points for setting up the correct implicit differentiation. So if you did the quotient rule, now their order is a little bit different than ours. The dy dx, we put it out here in front, but that's okay. It's all equivalent. So you got 2 points just for putting that. Now the key part was remembering you put dy dx in there. And then you got 1 point for the substitution for dy dx. So if I have a dy dx here and here, remember how we said that was equal to 1/4? You got just 1 point for that. And then you get 1 point for the answer, which this could be the answer if you stop here, or any form of it algebraically, the final answer is 1/32. And that'll take us kind of right up to the end of the hour. We will do a lot more with particle motion as we move along throughout this textbook. It's kind of slowly integrated throughout the whole thing. So some students find this really difficult to start. But let's read through this. And there's only 2 parts, part A and part B, which means there's a lot of points assigned to both of these. And I think most of the points for part B. But a particle moves along the x-axis with a position. So that's where I'm thinking, okay, I have the position function, which is just, we can't call it this, but you can kind of think of it as, that's my regular f of x graph, right? It's the regular original graph, and it's given at time t. So I'm actually going to erase this f of x, because that's not at all what we're referring to, but that's the way I frame our thinking. So here's my position equation, and it's on the interval from 0 to 2 pi. Our job is to find the time at which the particle is farthest to the left. Well, wait a minute. If I'm going to the left, that's when the left is referring to when the derivative is the most negative. Well, another way to say this is we're looking to find the, I should say absolute right here. We're just looking to find the absolute minimum value of the position function, right? Because if my position function tells me where I am left or right, if I find the absolute minimum of the position, that's going to get me furthest to the left. So this is just kind of a tricky way of saying, what's the absolute minimum? So here's what we got for part A. I'm going to start off, and I need to find the derivative. So the derivative is velocity, but it doesn't say anything about velocity here, so we should indicate what is velocity. It's the derivative of the position function. So I'm just going to state that in case I ever refer to something as velocity. Now the person reading knows what I'm thinking. It's the derivative of this function. And then I'm going to take the derivative, but notice this is a product rule. So if you want to do some side work here, you can. We've got u is e to the negative t. And if I take the derivative of that, it's going to be e to the negative t times the derivative of whatever's in the exponent, which is -1. I actually would write that negative out in front. And I'll do that down here. And then the derivative of sine is just cosine. You do not have to show this work right here. Okay? You can just say, yep, that's good. Well, now let's set up the product rule. So what is the product rule? It's the derivative of the first times the second. So I'm going to just take that -1 and put it out front. So -1 times e to the negative t is negative e to the negative t times sine. All right, and then we're going to take the derivative, or excuse me, the original first times the derivative of the second. All right, and I believe you had a question very similar to this on your last test. You were asked to find an absolute minimum or an absolute max, and you had a function where you had to factor it. Well, notice they both have e to the negative t in common. And if I factor it, this negative sign is left over. And the cosine, and actually, oops, this shouldn't be x. They would consider that a spelling error if you accidentally put an x instead of everything's in terms of t. And then we've got the zero product property. Well, this problem, if you remember the graph of e to the power of t, it's never going to equal 0. So I'm not even going to pretend to solve this. Actually, I'll show you quick. If I take the natural log of both sides, we end up with this, but the natural log of 0 doesn't exist. So this whole side, it doesn't give us any information, right? So that's not going to help us. And then we've got this part right here. Now there's multiple ways that you can solve this. If I bring the sign over, my brain says divide by cosine, so I get sine over cosine equals 0, or equals 1, and that's a tangent. But I was talking with Miss Hires, and she's like, well, why don't we just think of the unit circle, right? On the unit circle, when is sine and cosine the same value? That was the square root 2 over 2. So when are they both positive and exactly the same? That's at pi over 4. So that's one of them, but my interval goes all the way around. So now I have to think of the other spot where sine and cosine are both the same signs, and that's down here. And this is, so this would be 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. And I'm not going to go into great detail. If you need more justification, you could look at your unit circle and figure out this pretty quickly. But here are my values, right? Those are my possible spots at which a minimum could occur. But since we're finding the absolute minimum, we have to do the chart. And now we're testing the absolute value, so we're going to test the original function. And I'm going to test the endpoints, 0 and 2 pi, and then I'm going to test the two critical points, pi over 4 and 5 pi over 4. Okay. So remember, this is the original value. So I'm going to just take the original equation, I'm going to plug in 0, and that should be really quick. E to the negative 0, well, officially that's e to the 0 or 1. And then sine of 0, if you think of where sine of 0 would be, that's the y value is 0. So this whole thing is 0. And by the way, you don't get any extra points for showing this work right here. So if you can do it in your head, do it. If not, then we got to kind of set some things up. But notice, now I have to do sine of pi over 4. Well, wait a minute. I justified what sine of pi over 4 already is. It's square root 2 over 2. And it's times e to the negative pi over 4. Now notice, e to the pi over negative 4. All right? This part right here that I wrote very messy, that's going to be positive. And this number is positive. So this number is greater than 0. And that's all we really need to know, because we know that this number is not going to be an absolute max or minimum, because 0 is already less than that. Okay? And then the last, not the last one, but then we've got 5 pi over 4. Okay? Now here's the thing that you got to think of. What is sine of 5 pi over 4? Well, if we look at it, here's where 5 pi over 4 is, and this is the spot is go over negative, down negative. So both of these values, they're both square root 2 over 2's, but the cosine and the sine are both negative. So I know that this answer will be a negative square root over 2 over 2. I know that this part right here is going to be positive. So right now, this is my leading candidate for the minimum, the farthest to the left at 5 pi over 4. And the whole reason why is because of that negative value right here. So then the last one is we do have to evaluate it at pi over 2 just to see if the endpoints are going to give me anything different. But notice, 2 pi is the exact same thing as 0. 0 and 2 pi in the unit circle are exactly the same. So without doing any work, I know that this answer right here is 0, which makes the whole thing 0. So my answer right now is where, notice it says at what time. Okay, at what time is a particle farthest to the left? And it's right here because this is the furthest left, it's the absolute minimum. And then my justification, part of this is my justification, is just showing the derivative. We're running out of time, so I'm going to show you kind of how they did the work here. And we can just go through You got 2 points for the first derivative there. So if you got the derivative correct, right there, even not in factored form, you got 2 points. If you set it equal to 0, now notice, if you just set it equal to 0, they didn't show that work, but if you set it equal to 0, you got 1 point, and then if you answered it correctly, and you found out that 5/4 is the minimum, and then your justification is really the work that you're showing. So, okay, the last part is pretty tricky, and I'll just show this on here because otherwise it would take me quite a while. All right, so our job is to basically show that a times the second derivative plus the first derivative plus the original function, and that, let's actually use different colors here. There we go. So we have to show that those are equal to 0. Let me go back to the original problem quick. It says find the constant a value that satisfies this equation right here. Right? Now, keep in mind, what do we already know? We know the original function. That was given. Right? So that's just going to go right here. We found the first derivative. It doesn't matter which. I actually think I would take the original form and put that in here. So then we have to take the second derivative. And that second derivative is going to go right here, but times by a constant a. So this is a little bit tricky. I don't have my worked out solutions on here yet. So let me just show you what they did. Okay, they took the second derivative, and here's the second derivative. They factored out an e to the negative t already, but you'll notice if you distribute those, you're going to get some things to reduce out, which actually makes it less scary. Oh boy. Okay, so we're done with time. I don't want to go over. We can go back and look at this. Morning, everyone. Emma, can you hear me? If you can hear me, can you send me a chat just saying yes, you can hear me? Okay. So Emma, hang tight. I'm gonna create a breakout room and have a chat with you once we get everything set up. So just hang tight. I want to make sure I got you at the start of the hour. So good morning, everyone. We're still waiting for a handful of people to join. But if you could, we did that Chapter 8 project, and I put the comment in the wrong spot where I thought it was going to be something that you guys could see through the gradebook. So what you have to do is just open your project back up, and I believe you can do this. You might have to look in your gradebook to see it, and then just read through the comments. I put them, it might be on a specific slide, and I'll show you that in a second. Um, but if you can just open up your project and there's an editorial comment section or presenter comment section on the bottom. If you click through each slide, you'll find a spot where I entered in a comment.